Oh, yeah. Jack, you done?
No.
All right. If you would have said yes, I would have said, come here up here and do it before. Make sure you guys are getting the right p-hat. How do you set that up? How do you find the percentage from the sample?
9 divided by 6.
Yeah, 9 out of 54. Yeah, you could do 1667 or 167. At least 3 places for those. So Q hat would be 0.833. I like it. N was 54. What's N P hat? I put that here first because really I'm hoping some of you guys can do it without first figuring out what P hat is. You don't need that. P hat times N has to be 9. If you don't believe me, there's 2.167 times 54. You'll get something close to 9 because you have to round that. So that's 9, which is what? What do I check here? Yeah, it's greater equal to 5. Check. So what's NQ hat going to be the rest? That's 9, so this one's got to be, what's the rest? Say again? 45. How'd you know that? Well, 9 of them are here, so the rest of them have to be there. 9 and 45 make 54. I like it. And again, if you don't believe me, do Q hat times 54, and you get something close to 45. That is bigger than or equal to 5. Check. And what does that mean? That little check we just did, what does that mean? Normal enough. I'm allowed to use z-scores to get percentages and vice versa. What z-score do you guys get for 90%? Has anybody got that yet? 1.645. It's on the little baby chart too if you want to do a little shortcut. And now you got everything you need to plug into the formula. So I get 0.167, give or take 1.645 of these. Somebody save me for myself. I'm trying to do it in my head. Nobody's going to save me, okay. 0.8. So the 0.07 something? I don't know. Yeah, what'd you get for the answer?
0.0834.
All right, cool. It's close enough for me. 0.0834? And I just add that, subtract that to get the upper and lower part of the interval. All right, so if I subtract it, I get let's see, 0.836. 33? Yeah, okay. And then I get when I add it, I get 0.2504. Who? 0.1? Okay. Maybe? No? That makes sense. Close enough. All right. So then we are 90% confident that this interval, 8.33% to 25%, contains the true percentage of tires that are overinflated. What's that? Are you guys doing all right? So I always suggest you find the error first, and then you take that minus this and that plus this, that gets the lower and upper parts of the interval. So the only numbers we have to look up the z-score that goes with that idea, right? Mm-hmm. Okay. And nobody said anything, so I was hoping everybody was cool with that. Right? So if you had to draw it, it'd be 90, so there must be 10 outside, so there must be 5% on each side. So when you look it up, it's a little asterisk dude that takes you to this. This is right between two. And then everything after that is just plug and shove, right? Until you get to the part where you got to interpret what the hell you found. So from our study, could we say that, have we disproven that 1/4 of all tires are overinflated? Is this evidence that that's not true? 1/4 of all tires are overinflated. Is it evidence that that's not true? Could the percentage be 25%, according to what we found? Yes, why? Because it includes it. Is this evidence that it's less than 30%? Yes, it's evidence. Is it proof? No. Hell no. Why? Because we're only freaking 90% confident of what we found. But it's evidence that it's less than 30. Okay, I like it. I like it. Okay, a little preview, and then I'll let us out of here a little early. The section I skipped, section 8.2. The reason I skip it is because A1 and A3 both use z-score. They both use that standard normal distribution. Section 8.2 uses a different distribution. And I was just talking about why really quickly, and then I'll let us out of here. And this is related to somebody that worked at Guinness that was trying to do research, and Guinness, he couldn't do research and publish it. They would actually take it from him and have it be their own while he worked there. So he published it under a pseudonym, and he called himself Student. So it's called the Student's T-score. So let me ask you this. We have this formula right now. If I didn't know what that was, if I didn't know that standard deviation of the population, what's the next best thing I could use? If I didn't know the population standard deviation, now where did this come from? Sample. So what else could I calculate from the sample besides the sample mean? Sample standard deviation. So if I don't know the population standard deviation, which is definitely true most of the time, I'd have to use the sample standard deviation. Now, what did I just say earlier about statistics like punishing us for not knowing something? We've got to be more conservative. So if there's a piece of this I'm not as sure about, if I suddenly have to use a sample standard deviation, is that really the same as this? No. It should be close if my sample's decently random, but I know it's probably not the same. So to cover me, to cover my ass for not knowing something as certainly as I should know it, what should happen to my interval? Should it get bigger or smaller? Because I don't know something, it should get bigger to cover my ass better, right? So I should have to catch more stuff. I should have to catch more stuff to be equally confident that I caught the real whatever, right? The real mean in this case. You guys with me? So what I do in general, what we do is we don't use z-scores. We use these things that are always a little bigger than the z-score would be. So like if the z-score was 1.645 that I would use, maybe this score would be 1.8. What does that do for me? It covers my ass for not knowing something. Now, when are we more confident in this? What happens that we could do that would make us more confident in what we see in the sample? We can make the sample bigger. And then, of course, we're going to be more confident. As long as it's randomly selected, we're more confident in what we get. So this is called a t-score. The t-score, if the sample size is really small, the t-scores could be stupid big, because they got a lot of uncertainty to kind of cover us for. The bigger my sample gets, the smaller these get. Until I get a really large sample, and then these basically become these, because they're not really needed anymore when my sample's like really big. All right. So let me actually give you this before you go. Just because next time it'll help me remember who was here. Who's not. Say it.
Like the T at the
That's an S, yes.
S?
That's an S.
For what?
For what? What does the S mean? Guys? Sample standard deviation. Yes. Real quick, I want to point out to you. Before you race out of here, we got a lot more to talk about for this, but just to show you, I know this doesn't say sample size. Guys, this is related to the sample size, okay? We're going to talk about this later. But this is the sample size getting bigger. Notice how big the t-score is. Now, we also got to talk about this shit up here, but these are just t-scores for different situations. Notice how big the t-score is up here for a very small sample. But the bigger the sample gets, the closer the t-score gets to a z-score. This would be, if the area in two tails is 1%, what area is inside? The area outside is 1%. The area inside is 99%. The z-score for that, we did one earlier, was 2.575. Was the best we could do with the z-score chart. Look what is, if I get large, it becomes a z-score 2.576. Don't these other ones look familiar too? So the very last row of the t-score chart are z-scores. So we can actually use this chart to figure out z-scores. It always freaks people out, but it's because t-scores are just a little bit bigger than z-scores until you don't need them anymore. When do you not need them? When your sample is large. You got to love that the word large is here, because it's kind of individual what large means to people. Right? That's enough for today. We'll pick it up with t-scores next time. So you can do it one of two ways. Stefan, don't forget your probability that a sample mean is more than is basically 0%. And that's saying that. So that is evidence of something serious. If everything stays the same, that should be basically impossible. But then it just happened. But a slightly better way to do it would be to use standard deviation and go up two of those, down two of those, figure out how many it is. And then just say, wow, that's way above the max usual. It's unusual. Is this unusual.
Get any of this
I'd say.
stuff?
That's there.
Just look at the max and the min.
Oh, that's true.
Yeah, the min and the max to see what's usual, and then you can see that that would be way outside. Yeah, so that's evidence that something is weird. Yeah. Yeah, you don't, so you gotta remind me. You gotta do one. Email me, remind me. There's one over there. All right, you gotta make sure your emails are coming through to me, because I don't remember getting an email. Yeah, and just say, please email me back when you get this. And say, oh, I got this, yeah. Because I need to remember to get the makeup test over there. Sure. All right. It is a Z-score you're finding. Yeah, this is the area we're finding a Z-score, so it wouldn't be the percentage. Yeah, Z-score is just the number of cities.
Alright, bro. Yeah, true.
Oh, you gonna make corrections? You already did. Oh, you already did? Yeah. Oh, if you're all set, then just start right. Yeah. Rest your hand.
When you take out when you add the homework, it doesn't go up that much. When you take out the homework, it goes down to 6 points.
You ready? You ready?
Yeah.
If you had 100 average without the homework, and you had 100 homework average, your grade doesn't change at all.
It doesn't.
You understand? Why would it change? There's 100 average on the tests and quizzes, and you have all the homework turned in. Your grade stays at 100%. You with me?
Yeah, but it's not the same thing though. Because this time, like, if we're trying to follow the homework, it's only gonna go up 2%. But if you don't do the homework, it's gonna go down a letter grade. I'm like, how is that even possible?
Of course it is. That's the way it is. Because that's the extreme. As you approach one or the other extreme, you can see why it's working the way it is. If you had 100% average and you have 100% of the homework turned in, you have 100. It doesn't change your grade at all. If you have an 80% average and you have 80% of the homework, it doesn't change your grade at all.
Okay. So
Right.
when I turn in the homework, is you gonna give me like half basically? If it's all done, you're gonna give me half credit basically. Because I'm missing like all the homework basically.
Oh, I see. It depends on how much and how late. Yeah. So, I mean, the incorrect way to look at homework is to see what it gives to you grade-wise. The correct way to look at homework is it's practice. So you do better on the test in the first place, right? So the homework, to me, I don't want to count homework for anything. I don't want it to affect your grade at all. I wish I could make homework worth 0.
You should.
But if I did that, nobody would freaking do it. Because how do I know? I've done it once, and I'm never going to do it
You did
again.
it once before?
Hell yeah. Way back the second semester I ever taught, I did it. And nobody did the homework, and they all did shitty on that first test. And I was like, okay, let's not do that again.
Oh, okay.
It was a pre-calc class. I thought they could handle it. No, they're human. So what are they going to do? They're going to do the homework that's due, and not the one that's never due. That there's, So I assigned homework. I said you don't have to turn it in. You can just ask questions from it. Nobody did it.
I know.
So I've got to make it worth something, a little bit.
But you got to see like to us hard workers. You got to, you know what I mean. We're turning the homework. You know what I mean. Just
Well, then you're doing what's good for you. That should reflect on your test grade then.